Hi everyone. Today we're taking a look at doing some more simplifying, some more rewriting. We're not at identities yet, but we're headed there. But before we do, something came up with graphing that made me a little concerned, and I want to take a look at a couple of pictures and have you tell me what's my period. Okay, so here's your first function, here to here, and this is pi over 6, and this is 7 pi over 6, and this here is 4 pi over 6. So the thing is that even though we're done with this graphing unit, this idea of knowing the function's period, yeah, that doesn't go away. In fact, we needed a whole bunch when we do our trig word problems unit. So what's my period? Well, we want starting x. No, we want ending x minus starting x. So my period goes from high point back to high point. I mean, if I had another low point, I could do low point to low point or inflection point to inflection point. But here, I'm going from high point to high point, so I'm going to have 7 pi over 6 minus pi over 6 is 6 pi over 6, or pi. Okay, so what's my period? My period is pi. So will you tell me what the period here should be? This is 5. This is 25, and, oh, sorry, that's minus 5, 25, and 10. What's the period here? 25 minus a minus 5 is 30, not 20. You're subtracting the negative 5. The distance from here to here is 30. Think about a number line with 0 there and negative 5 and positive 25. This distance is 25, and this distance is 5 more. So the whole distance from start to end is 30. Okay. How about this one? Yeah, how about this one? So here we have negative 1, we have positive 4, we have positive 9, we have positive 14. So is our period going to be 14 minus a minus 1? No, that's more than one period. If I'm starting here and I want to get back to here where the graph starts going down, that's this place. This is the place where the graph starts going down. Going down to going down. Yeah, So the period goes from here to here. So I should have 9 minus a minus 1 or 10. Okay. Yeah, I guess I could go from here to here. And this is the place where my graph goes from negative to positive. And this is the graph going from negative, and it's about to go positive. Then I could do 14 minus 4, also to get 10. But 15? No, that is not the period there. Okay, how about this last one? We know that this is pi over 2, and that this is pi. Okay, so what's my period? Well, so here's the thing. This can be the start of a period, but that's the end of the period. Because after this, I'm repeating myself. This could be the start of a period, and that's the end of a period. So what I'm really looking at here is 2 periods. Okay, well, let's find that distance. Pi minus pi over 2. 2 pi over 2 minus 1 pi over 2 is pi over 2. Great. So pi over 2 is the distance from here to here. Pi over 2 is 2 periods. Well, but I only want 1. So let's divide both sides of this by 2. And I get that 1 period equals pi over 4. Okay? The distance from here to here is pi over 4. The distance from here to here is pi over 4. So if I make this by 3 pi over 4, 2 pi over 4 plus 1 pi over 4, 3 pi over 4. 3 pi over 4 plus 1 pi over 4 gives me 4 pi over 4, or pi. There it is. Okay? Can you focus that a little more? It's a little better, yes. Okay. So, yeah, when we get back to word problems, please, you're going to need that information. Okay, so here we are. This is, what is it, the sum of 28? 28. And we're simplifying a little more. Day 2. Right. Sine squared y over 1 minus cosine y. Okay, so what do you want to do? Oh my goodness, I see another strategy. No, that's not sine y. Remember, it is true that 1 minus cosine squared y would equal sine squared y. It is not true that 1 minus cosine y equals sine y. That is not true. No, no, no. Yes. So I could turn this into 1 minus cosine squared. Okay. And that's all over 1 minus cosine y. And then, no, I can't cancel like that. Oh my goodness, no, stop that. If you see your friend doing that, you just smack that pen out of their hand. No, really. You can't. You'd be telling me then the answer is cosine. Well, no. No. Goodness. This is a difference of squares. Let's factor it. Why don't I want to rewrite it as sine squared, you said? Well, it just came from there. I just took sine squared and turned it into that. Why would I want to turn it back into sine squared? Yeah, no. What am I going to do from here that's not going back to sine squared? Well, that's a difference of squares. That's 1 minus cosine y, 1 plus cosine y, over 1 minus cosine y. Cancel. And so my simplified version is 1 plus cosine y. And there's no way you're getting 1 plus cosine y out of that if you think you can do this canceling like that. Yeah, no. So don't. Stop it. Now, that's what most students do. But I saw another strategy. And here it is. Strategy number 7. I think we were up to 7. We said factor. We said distribute. We said split. We said make a common denominator. Yeah, so here we go. And I'm going to say multiply top and bottom by the conjugate. Yeah, so guess what? It turns out that sometimes multiplying top and bottom by the conjugate is in fact the fastest way to do the problem. I don't think that's going to be the case here, but let's take a look. So the conjugate would be 1 plus cosine y. Okay. I FOIL on the bottom. What do I get on the bottom? So sine squared y times 1 plus cosine y. And on the bottom, I'm going to have 1 minus cosine y plus cosine y minus cosine squared y. Cosine squared y. Hey, isn't 1 minus cosine squared the same as sine squared? And then these cancel, and I'm left with the same 1 plus cosine y. Done. Okay? So, we were able to multiply top and bottom by the conjugate. Good, that worked. And the other way was to use our identities here and say, oh, sine squared, that's 1 minus cosine squared, and then factor the difference of squares so we could factor this factor in the denominator out. Okay, wow, that's kind of exciting. I get to do some thinking with these problems. So what's next? Well, how about this one? Secant x minus tangent x. So here's what most students want to do. They want to do 3, 1 over cosine x minus sine x over cosine x. And then they say, oh, look, a common denominator. And so that's going to be 3 over 1 minus sine over cosine. And then they say, oh, we can do flip and multiply. 3 times cosine x over 1 minus sine. And yeah, I don't see, well, what if I use the conjugate here? I'd have 1 plus sine 1x, 1 plus sine x. On the bottom, when I FOILed out this difference of squares, I'd have 3 cosine x, 1 plus sine x over 1 minus sine squared x. Okay? What is 1 minus sine squared x? Well, that's the same as cosine squared x. Huh. Okay, so I can cancel that with one of those. And I've got 3 times 1 over cosine times 1 plus sine. Ugh, I don't know. That doesn't seem particularly tidy to me. What if I distribute this? I'm gonna have 3 1 over cosine plus sine over cosine. I guess that's secant. And that's tangent. And so I get to here. Well, that was a bunch of steps. Why not just do this? Instead of all that work, let's multiply by the conjugate. Secant x plus tangent x. Secant x plus tangent x. Cool. I FOIL on the bottom, and I end up with secant squared minus tangent squared. And on top, 3 secant x plus tangent x. What's secant squared minus tangent squared? 1. So if I'm dividing by 1, there I am. I'm all done in 2 steps. Conjugate can be this really helpful thing. When I rewrote this in terms of sines and cosines, and then made a common denominator on the bottom and flipped and multiplied, there was a lot more work to that than multiplying top and bottom by the conjugate. So, lots of roads that we can take, but some of them, yeah, not going to be happy taking those roads. Okay, so what's next? How about, yeah, we're told that we've got these 2 functions, one cosine x over 1 minus sine x, and the other one, 1 plus sine x over cosine x. And what we're asked to do in this problem is show that these 2 functions are the same. Really? The same? Yeah, the same. So, how about with this one? We take cosine x, 1 minus sine x, and which strategy would you recommend? It's already written in terms of sines and cosines. I don't see any factoring. I don't see any distributing or FOILing. I've got 1 fraction. I could split it into 2, but over here I still have 1 fraction, so I don't think that's what I want to do. And since I don't have 2 fractions, I can't make a common denominator. So right now all I'm left with is conjugate. So on top I'm going to have cosine x, 1 plus sine x, and on the bottom when I FOIL, I get 1 minus sine squared. What's 1 minus sine squared? 1 minus sine squared is cosine squared. So on top I have cosine, 1 plus sine, and on the bottom, cosine squared. So I can cancel that with one of those. And what am I left with? There it is. Hey, let's have strategy number 8 now. Strategy 8. Look where you are going. Okay? I used it at least once here, where I said, I've got to get this to be one thing on the bottom. I've got to get this to be two things on the top. So I was looking at that and I thought, well, you know, when we've done this conjugate thing before and gotten this Pythagorean rewrite, I can turn it into one thing. Oh, okay. Yeah, when you get stuck, look where you're going and say to yourself, hey, I'm stuck here. Is there any way I can get from here closer to here? Oh, look, I have a 1 plus sign. So that means that there has to be something's going to happen with this stuff to turn it just into cosine. Oh, hey, isn't that cosine squared? Yeah, see what I mean? Like, if you get to that stuck place and you go look where you're trying to go and say, well, how can I go from where I am to where I want to be? Not having to change this one because this is the same in both. So this stuff somehow needs to turn into that. Okay? And you know it. Yeah. No, I'm not going to do that one yet. Okay. So, but we can also go the other way. 1 plus sine x over cosine x, and we're showing why that's equal to cosine x, 1 minus sine x. Well, again, I think conjugate is perfect here. I mean, you could do this. You could break this up into two separate fractions. But this is tangent. This is secant. But then what? Like, I get stuck there. I don't know how to get closer to that. What the hell are these? I don't have any of those over there. And so, you know, some students say, oh, don't worry, Mr. because you know that secant x plus tangent x equals 1. And no, I don't know that at all. I know that secant squared minus tangent squared is 1. But secant plus tangent? No. Sorry. Could be 1. Probably isn't want to be 1. Yeah. So, uh, not keen to split that up into two fractions. And the cool thing about having a strategies list is, well, this is what we thought to try first. I'm not getting closer. I'm feeling like I'm getting further away. Here I have one fraction. Here I've got two separate fractions. I'm just not feeling the love. So sure, go back and try a different strategy. And that's what I mean about being engaged with the strategies list, right? You want to be really comfortable with all your options there. And I think this is a perfect time to use the conjugate. And so I'm going to FOIL on top, and I'm going to have 1 minus sine squared. I'm going to resist the temptation to distribute on the bottom. Why? Well, when I look at where I'm trying to go, I'm supposed to go to this place that says cosine over 1 minus sine. And I've already got the 1 minus sine. Why do I want to screw with that? No, don't distribute. So, but I can say something about that. 1 minus sine squared. It's cosine squared. Cosine 1 minus sine. And so lo and behold, I can cancel a cosine, and then I get where I'm going. All right? You could always type y1 into y1 and y2 into y2 and graph them and see that they graph on top of each other. But that's not the intent of this problem. The intent of this problem is for us to be able to turn one of them into the other. Yeah? So it doesn't matter to me which you turn into which. I just think you should be able to do. Okay? So what's next? There's a bunch of stuff here. So next, yeah, so they would really like us to use our calculator and to explore. Have the calculator be that device that can, it's cotangent x plus sine x. Okay, so they say you're supposed to simplify this, but you should probably graph it first. Okay, cosine, that's going to be, oh look, I have cosine there. Cosine times, I don't have a cotangent button, Mr. Kukla. Yeah, I know. So that's why I'm going to do times 1 divided by tangent. I've got a tangent button. I'll use 1 over tangent for that. Close that parenthesis, right? you don't close that parenthesis, the calculator automatically opens this parenthesis. If you don't close that parenthesis, the calculator thinks you mean this. And you don't mean that. So close that parenthesis, then a plus symbol, and then a sin x. Okay? So zoom, and how about zoom trig? 7. So what graph is that? It kind of looks like a secant or a cosecant graph. Kinda. Yeah, let's take a look. See what we get. So I know that this is cosine over sine. And I've got times cosine and a plus sine. Well, that is cosine squared. Two things. I can't add them unless I have a common denominator. So I'm going to multiply top and bottom by sine. Ooh, cosine squared plus sine squared over sine. What is cosine squared plus sine squared? See, you really do need to know your identities. Cosine squared plus sine squared is 1 over sine. And 1 over sine, cosecant. Yay! So they were asking me to graph on my calculator to see if I knew where we should be going. Right? I don't know where I'm going. What's this supposed to be equal to? I don't know. I certainly wasn't expecting cosecant when I looked at these objects. But when I looked at the graph, I said, hey, that's a familiar graph. And then maybe that can help guide your steps as well as part of look where you're going. All right? How about this one? 1 over sine x times 1 over cosine x minus cosine x. Again, they say, why don't you graph this to get a sense of what it's supposed to be? I think, frankly, typing this in is going to be a little pain in the butt. But, you know, there might be some value in this experience for you. So let's take a look. 1 divided by sine x times, close that parenthesis, times 1 divided by cosine x, close that parenthesis, minus cosine x, close that parenthesis. Okay, and graph. Yeah, so whose graph is that? Well, going from negative pi over 2 to pi over 2 sure does look like tangent. So this is going to turn into tangent, I expect, when I'm done. Huh, that's interesting. Now, which person are you? Are you the one who wants to distribute, or are you the one who wants to make the common denominator? Me, I'm the one who wants to make the common denominator. And here's why I want to make the common denominator. Because now I see on top 1 minus cosine squared over cosine times 1 over sine. What is 1 minus cosine squared? That's right, it's sine squared. So I can cancel that and that. And now I've got sine over cosine. And sine over cosine is tangent. Okay? Now, what about that distributing person? Well, let's take a look. Distribute, distribute. I've got 1 over sine x cosine x minus cosine squared x over sine x cosine x. Okay, common denominator already there. And so, and what's 1 minus cosine squared? Yeah, by now you should know that that's sine squared. And look, and now we've got sine over cosine, which is tangent. So yeah, I just really appreciate, I really love how there can be really different approaches to the problem, and they can all get us there. All right, so Calc 2. In Calc 2, this could be really, really helpful. Not AP Calc here at Sabino, that's Calc 1. In Calc 2, the class after our AP Calc class, this could be useful. They're saying, hey, 3 cosine theta. They're saying, why don't you simplify this expression by using a trig substitution? So here's x being squared. Here's x. So if I square both sides, I'm going to have 3 cosine theta squared. And that's going to be 9 cosine squared theta. Okay, so let's replace x squared with 9 cosine squared. What's that going to look like? 9 minus 9 cosine squared. Well, that's cool. Look, I could factor out a 9. And I'm left with 1 minus cosine squared. What's 1 minus cosine squared? Good job. 1 minus cosine squared is sine squared. So I take the square root of 9. I take the square root of sine squared. Okay, so this, we're going to be okay if you write that. But really, what we saw last semester was when you take the square root of sine squared, I'm actually getting that. Yeah. Cool kids give me that absolute value. But really, if this is your terminal math class, or you hope it is, then that's going to be fine too. But look, we turn this into that by using a trig substitution. Ooh. Okay, so how about you take a look at this one? Square root of x squared plus 25, and x should be 5 tangent theta. Will you try making that substitution and simplifying that expression? Sure, x squared is going to be 25 tangent squared. So this becomes 25 tangent squared. And I'm going to factor out a 25 from these two terms, leaving me tangent squared plus 1. What is tangent squared plus 1? Secant squared. Good. And the square root of 25 is 5. And the square root of secant squared is, yeah, I'll let it slide. Maybe Mr. Claus will not. But really, that's a little better. Okay? All right. So I think that's kind of cool that we can do these. And in fact, yeah, in Calc 2, you do need to use trig substitutions. Let's take a look at a solving problem. Now we want to solve. And we're told on negative pi over 2 to pi over 2 is where we're looking for our solutions. Okay? And then it says, then find sine of theta and cosine of theta. Well, I'm not quite sure what that's all about, but let's see what the problem says. 3 equals square root 9 minus x squared, comma, x equals 3 sine theta. Okay, well, from the last two problems, I see that I'm supposed to do a substitution here. X squared should equal 9 sine squared. Cool. So I'm going to plug 9 sine squared in there. Oh, this feels a lot like that problem we just did, doesn't it? Okay, and then here we take out that 9. Good. Don't forget, 9 divided by 9 is 1. If you don't do 9 divided by 9 is 1, you end up getting stuck in this problem. 1 minus sine squared? What's 1 minus sine squared? Okay, so 1 minus sine squared is cosine squared. So we took the square root of both sides, and students write that. divide both sides by 3, I get then that cosine theta equals 1. When does cosine equal 1? When theta equals 0 or 2 pi. Well, we were supposed to go from negative pi over 2 to pi over 2, so 2 pi way too big. So that's my answer. Okay, so theta is 0 radians. Remember, they also wanted me to find sine and cosine. And how can I do that? Well, this is the angle. So what's the sine of 0? Sine of 0 is 0. And what's the cosine of 0? 1. Okay, so those are the 3 things they asked for. Okay, what about solving this one? Sine theta equals square root 1 minus cosine squared theta. Okay, so that's sine theta equals 1 minus cosine squared. Oh, please, child, know that that's sine squared. Now, square root, so are we going to say this? That feels uncomfortable. Does that mean that they are the same and that we have infinite solutions? Well, let's take a look at this on our calculator. I'm going to grab this in y1, and I'm going to grab this in y2. And let's see what we see. Okay, y1, I've got sine theta. y2, I have square root of 1 minus parentheses cosine, close parentheses, close parentheses squared, close parentheses. Because I opened 3, so I had to close 3. Yeah, so when I want to do cosine squared theta, in my calculator, I have to do cosine theta. So I've got that to close, and that to close, and then I'm saying squared. Okay? All right. So we've got sine in y1 and in y2, square root of 1 minus cosine squared. Great. And we're supposed to look here, I think it's 0 to 2 pi. It's not the same, negative pi over 2 to pi over 2. 0 to 2 pi. Okay, so I'm going to change my viewing window. Wow, look at that viewing window. No, I'm going to go from 0 to 2 pi in steps of, pi over 4. Pi divided by 4. My y values. Well, I know that sine goes from -1 to +1, so I'm going to run with that. Okay, graph. So, what's up? Mr. Kukla, are you in radians? Child, I don't think I'm in radians. So, let's say, when you're graphing, better be radians. Okay, so there's our sine theta. It's very sine theta-like. And now comes this one. What the hell? So here's the thing. If you're this person who's saying, oh, this is going to be sine squared, and the square root of sine squared is sine, then you expect y1 to graph sine and y2 to graph sine, and you expect them to sit on top of each other. But guess what? They didn't. They did for this part, and then we saw that. And you know what that is? That's the absolute value of sine. Right? Sine wants to do this. Absolute value says you're going to do that. So there's my absolute value of sine. And my sine looks like this. So these graphs intersect from 0 to pi. But, like so. That's my answer on 0 to pi. I'm not going to include 2 pi because there's a parenthesis there, and yes, I did include pi. Now, should you worry about that? No, not in our class. I really wanted you to see that, but I wouldn't put something like that on the test. Were this honors trig? Yeah, that'd be a great test question. So Yeah, that's what we're going to do there. Anything else? Ooh. Yes, I have just a couple more to look at with you. So, this is a solving one. No, I don't want to do this one. This is another absolute value thing. Ooh, that's what I wanted to look at. ln cosine x minus ln sine x. So, use your log properties. Two logs joined with subtraction. They can be rewritten as one log with division. Cosine over sine, cotangent. There you go. Done. That's all we have to do. Just use our log properties. So maybe you can use your log properties on this last one. ln cotangent x plus ln 1 plus tangent squared x. Please use your log properties to simplify that expression. Oh, are you back already? Excellent. So let's take a look. Two logs joined with addition. Well, that's going to be one log cotangent times 1 plus tangent squared. Okay. So one log with multiplication. Okay, 1 plus tangent squared. What can you tell me about that? I agree, secant squared. Can we go any further? Well, cotangent is cosine over sine. And secant squared is 1 over cosine squared. So I can cancel one of those with one of those. And so I end up with the ln of 1 over sine times 1 over cosine. And maybe we could tidy that up a little more and say that's ln of cosecant times secant. Okay, there you go, another substitution. Things like this make second year calc easier. Whether you'll remember them by then, probably not, but you'll have been exposed to them and you'll have this little memory thing in your brain, and that's kind of cool. Okay? That's okay. I think that's it for today's video, and I think you're going to really like the next video more. All right, have a great day, everyone. Bye-bye.